Okay, so a couple of weeks ago, a few weeks ago now, about a month ago, I was asked to speak at a local beekeeping club here in southwestern New Brunswick on a topic of my choice, and really the only topic around honeybees that I feel comfortable or knowledgeable enough to speak with any degree of confidence is on the topic of honeybee nutrition. So that was the topic that I chose, and I created about a 15 slide or so PowerPoint presentation to kind of guide me through that presentation. And I figured I had the presentation created, that I might as well voice it over and make it available to a somewhat broader audience, for better or worse. So again, I'll just preface this discussion with a little caveat for myself, and that's, I'm certainly not trying to tell anybody how to keep bees in this initiative, just formulating some of my own thoughts and kind of opening up the doors to my feeding, supplemental feeding and nutritional strategy planning operation, and basically how I view the annual cycle of the honeybee and some of the steps that I've taken as a beekeeper to help even the playing field in my apiary and remove some variability. So we'll get going. So I've arbitrarily chose the title of Beekeeping with a Plan. So an overview, we're going to ask two primary questions. First primary question, then a secondary question to help us answer the first question. So is nutritional supplementation necessary for successful beekeeping? So that's a large, loaded question. What factors are influencing the nutritional demand or load or requirements of a managed bee colony? And I think if we can answer that question or shed some light on the answer to that question, it'll help us make up our own mind individually on whether or not nutritional supplementation is necessary. So we'll look at some of those factors influencing the nutritional demand of a managed colony and compare that to what that might look like in a natural or feral setting for a bee colony. We'll talk about early spring population dynamics. We'll talk about spring and early summer population dynamics. We'll talk about late summer and fall population dynamics, and we'll touch on winter population dynamics as well. First and foremost, pollen and nectar are king. True substitutes do not exist. Supplementation is highly useful, and it is highly successful when it's used to bridge the gaps in the natural cycles or flows of pollen and nectar. So that's really what we've been able to achieve so far in honeybee supplementation or dietary supplementation, is we've been able to bridge the gaps, but we've never been able to, we can't sustain long-term a honeybee colony on the current supplemental feeds. And that's in large part been the bulk of my efforts over the last 7 years or so, is to try to figure out that puzzle. There has been some substantial progress made in those efforts, but that isn't the point of this presentation. But currently right now, true substitutes do not exist on the market. So note here that cycles of natural forage vary in their quantity and in their timing from season to season, and the reliance on these cycles to produce adequate nutrition has been the demise of many managed bee colonies, and tens of thousands of bee colonies die each year by what I would call operator error or operator reliance on these natural cycles to produce adequate nutrition. And we'll dig into this a little bit more in the population dynamics section of this presentation. Thermal stability and its impacts on the nutritional demand of a colony. So what I have up here is a graphic that was produced as a result of years of work by Dr. Tom Seeley and his colleagues. So if anybody's interested in the biology or the behaviors of a natural or feral or wild honeybee nest or honeybee colonies, Tom Seeley's work really stands out in that field of study. So what they basically were doing over a number of years is going out, hunting down bee trees and tracking down bee trees, finding them, cutting them down and opening them up and taking the dimensions, looking at the internal structure. And basically what you're looking at here is the mean or the average representation of what a bee tree would look like. And this is typically facing south when they can choose it. They prefer south facing. Obviously for the collection of solar thermal gain, a warm front face in the wintertime is good for them. You have basically about 4 or 5 inches of wood typically on the side. So that's about R1 with some variability, some variation between, species to species variation in the R value. But you have about R4 or 5 of thermal resistance on the sides, almost unlimited R value on the top, almost unlimited R value on the bottom, no upper entrance, and the one small entrance, typically about 2 square inches in the bottom third of the colony. So this is basically, I think the message to take away from this is, our winter configurations. I think we would be well served to chase this design, and that's exactly what I'm doing in some field trials that I have set up, and I'm trying to get closer and closer to this natural setup. If this is what they're selecting in the wild, I think there's some wisdom in trying to pursue that. We'll see how that goes. I'll certainly keep everybody updated on the progress there. So that's under the trial winter configuration updates. As you see me kind of posting along that thread line, that's the initiative, is to be able to reproduce this with some more modern materials. So some things to keep in mind here about thermal stability and its impact on the nutritional demand of a colony. Keep in mind that the natural colony or hive population density in the wild for honeybees is estimated to be 1 colony per square kilometer, again according to the work of Dr. Tom Seeley and others. That's not how we keep bees. We keep bees in fairly densely populated yards. For practicality purposes, I would burn a large amount of fuel in my 1 ton if I had 1 colony per square kilometer. It's not practical. It may be achievable for the hobby beekeeper, but most hobby beekeepers keep a few colonies, and most end up developing a fairly good size apiary. I think the message here is that we should be spreading our bees out as much as possible. And most beekeepers know that. There's a number of reasons why bees pursue that stocking density rate. It's a part of their reproductive strategy to maintain some depth to the gene pool. Maintaining genetic diversity, disease transmission plays a factor there. And also, obviously, forage availability within that 1 square kilometer. So keep in mind that wild colonies are maintained or maintain themselves at much smaller populations than that of a managed colony. So we keep bees a lot larger, bee colonies a lot larger than they would in the wild, because we prevent the act of swarming. We need those numbers for whatever your objective is in beekeeping, whether it's splits or nukes, or whether it's honey production, or whether it's pollinating units you're trying to create. That all requires a large nest of bees to produce that. And also keep in mind that the thermal resistance of a bee tree is much greater than that of a modern Langstroth removable frame box. So all of those factors that I just referenced there are all creating a higher demand, or a higher nutritional demand, in a managed colony versus that of a colony in the wild. So when you're keeping bees in your backyard, or you have an apiary starting to develop, it's important to understand that that's not a wild unit. That's not under its natural conditions. So we're changing the metabolic load on that nest just by the way we keep them. So I have a note down here. Langstroth's original writings on his hive design called for a double-walled hive body with an insulating layer between the double wall. Langstroth apparently understood the bee preference for thermally stable housing. So whether the bees have to work, so our thin, we're 3/4 inch, pine boards typically for the sides, and there's a lot of upper variation. There's a lot of beekeeper preference to what goes on top in the wintertime, what goes on for wrap. But throughout the year, we have basically the bees in managed boxes have to work harder to heat their nest in the wintertime, and they have to work harder to cool their nest in the summertime because of greatly reduced thermal resistance of the boxes we keep them in. That's a metabolic load. That all of those activities, whether it's water collection and fanning for cooling in the summertime, or pumping flight muscles for heat generation through the wintertime, that's a metabolic load that requires carbohydrate and protein and all of the other phytoelements that are in those compounds as well. But that's upping the nutritional demand, basically, is the point that I'm trying to make. Pathologies, immune activation, and immunocompetence. So there's a fairly aggressive list of pathogens, and this is not a complete list. I ran out of room on the slide, essentially. Not a complete list. The honeybees are under an intense microbiological state of challenge in modern apiculture. So what keeps our honeybees in a state of relative health through this intense microbiological challenge is a robust immune response, both at the colony level and at the individual level. To explain that in a little bit more depth, colony-level immunity can be described as a series of behaviors such as propolis collection, nest cleaning activities, hygienic behaviors, etc. So at the social level or at the colony level, they have a series of biological behaviors that act as an immune system for that colony. Now, at the individual level of analysis, the bees have two primary mechanisms in their individual immune systems, and that's cellular immunity and humoral immunity. And it's very similar to, like in concept, that type of immune system breakdown is common, not just in the insect world, but also in the world of vertebrates as well. It's just a lot simpler, a lot less complex in the insect world. So cellular immunity, in the cellular defense mechanisms of a honeybee, bees have free blood cells called hemocytes within their open body cavity. Different types of blood cells have important roles in the protection of bees against foreign invaders. Notably, or primarily, exclusively, plasmacytes and granulocytes are the major hemocytes. They react to foreign invaders by way of two processes, and that's phagocytosis or encapsulation, basically the engulfment or eating of foreign invaders. Humoral immunity. The humoral immune response is the synthesis and secretion of antimicrobial peptides, or AMPs. For humans, it's most notably, for vertebrates, it's most notably antibodies. Bees don't produce antibodies. In their humoral immune response, they produce antimicrobial peptides that accumulate in the hemolymph of the blood against invading pathogenic bacteria. And there are a total of 6 antimicrobial peptides that are found in the honeybee. So, very important note here is that both colony level and individual cellular and humoral immune response requires adequate carbohydrate and protein for optimal function. Most colonies are one nutritional stress event away from a disease state. That's really a very important message here, and good beekeepers that have success over the long term understand the value of keeping the protein levels high in their colonies at all times. When you allow your colonies to experience protein stress, well, be it early in the spring, when there's a lot of weather variability and foraging days are few and far between, that puts a nutritional stress on the colony, making disease expression a lot more likely in your apiary. Or whether it's later in the summer, allowing your bees to experience that dearth situation, in July and August, that nutritional stress event. Immediately the bees, the immune system, both at the colony level and individual level, go down, making your apiary more susceptible to this list of nasties. That's a very important concept to understand. It's not complicated. Most beekeepers understand it, but I'm not speaking to everybody here. But there's some concepts that need to be applied, basically, to gain some consistency in our operations. So pathologies, immune activation, immunocompetence continued. I didn't think this discussion would be complete without talking about the benefits of having adequate propolis collection in our hives. So the role of propolis in creating and maintaining colony well-being is beginning to be more clearly understood. There are some practical management level adjustments that the hobby and possibly even the commercial beekeeper can make to create a healthier apiary. So honeybee collection of propolis has been largely bred out of their behaviors in the early days of breeding programs. I'm going to make a bold statement here, but I believe it to be correct. This is one more reason why current breeding programs are a bad idea. There's probably a lot of people that are ready to throw a wrench through the screen at me when I say that. But I just got to call a spade a spade. I think our current activities to breed honeybees are not producing the intended result, nor do I suspect that they will in the future. There's no free lunch in genetics, and the more we chase specific traits, the more we're giving up overall genetic diversity. I'll use the primary example of when we started breeding dogs from wolves. Wolves are a very fit, robust, naturally selected or created animal, requiring very little human input to survive on their own. You take our breeding efforts. We have bred them down in various shapes and sizes for specific traits. And it's not that we can't do what we're trying to do with honeybees, because we've proven it in other animals. But what we end up creating in every case, are animals that require a lot more input in terms of animal husbandry to maintain them. They lose their fitness over time in terms of their natural ability to survive. Nature is the best selector, and that's how I've chosen to run my rearing program is under the breeding selection of nature. And it's very easy to do that. It's actually much easier to do that than it is to chase the current program structures. So without kind of getting on a side note too much there, this is, in my opinion, this is a bad idea, and I think we're going to look back on these days of honeybee breeding, and the folks of the future are going to laugh at our toilings of today. Okay, Propolis benefits in the colony. So I won't dig too much into the literature here. It tends to get a little bit dry, but I do encourage anybody who's interested in the hive benefits of propolis. Just put a Google search into Google Scholar or a similar search engine, and you'll find a number of recent publications on this topic. So the individual impacts have been verified in research, have been a relaxed investment in immunity, and that why it ties into this presentation is because the more honeybee's immune system at the colony level or individual level has to be activated to deal with those microbial challenges, that's more of a metabolic load. And I think I use the analogy in my mind to kind of formulate my thoughts on this topic. As you know, I think of a bee as a small battery, an individual battery cell, and the more they have to forage, the farther they have to go for forage, the more they have to work to keep a hive warm, the more they have to work to keep it cool, the more their immune system has to be activated. All of that is a drain on the power of that battery, and the more load you have on that cell, the quicker that cell is going to wear out, and the quicker you have your battery cells wearing out in the hive, the less overall performance you're going to have of that colony unit. You want those energetic investments to have optimal efficiency, across the board, and that'll ultimately end in healthier, fitter, more productive colonies, in my estimation. So you also have an increased detoxification or an upregulated detoxification system within the honeybees. And antioxidant levels, and that's primarily the whole detoxification genetic pathway in the bees. Is there's a genetic pathway, the P450 genetic pathway in the bees, and that the P450 gene sequences is common across a lot of species. To perform those types of functions, but there's compounds in propolis and pollen and nectar and honey that are research verified to upregulate or turn on those gene sequences that allow for greater antimicrobial peptide production and detoxification, which also leads to an increase in their lifespan. At the colony level, the impacts are reduced microbial load, decreased disease expression, and an increase in productivity, population size, and overall survival. So those are some pretty serious benefits that have been research verified in the last few years. So I guess the message here, ultimately for the newer entry or even an intermediate level beekeeper, is to try not to have borderline obsessive compulsive disorder with your hive tool. Every time you crack the lid of your hive, it's fairly common thing that I see when I'm in the yard of somebody who's really not. I wouldn't say it's not only a new beekeeper thing. It's just kind of something that we do almost habitually, is just scrape those top bars clean. That's unless you're doing it to put a queen excluder on, or there's some mechanical reason why it needs to be removed. Leave this stuff in there. It's very beneficial to the hive. Varroa and its impacts on colony nutritional status. So, to talk about this monster, I'm not going to spend a whole lot of time here, although I should, because it's very important. It's just I think everybody's almost Varroa'd out. but you really need to understand that this is the primary problem right now in beekeeping. Pesticides, herbicides, and fungicides, although problematic, are not the number one cause of colony mortality. It's Varroa mites, the viruses that they vector, and the increased nutritional demand that they put on the colony. So it was recently, found by Dr. Sammy Ramsey, that Varroa are actually not feeding on the hemolymph or the blood of the honeybee. They're feeding on the equivalent of the bee liver or the fat body of the bee. And that's of huge significance because that fat body, storage, the development, the production, and storage of vitellogenin, antimicrobial peptides, the cells that work in the cellular immune system of the honeybee, the hormones, the ectosteroids that are responsible for, the phase changes of the honeybee from egg larva pupae onto adult honeybee. All of those are driven by compounds that are created in the fat body, and you have this little vampire, by the thousands, sucking on that organ system. That produces, all of that, key physiology inside the individual honeybee. So it's very important to manage Varroa, and the target needs to be 0 in this day and age. Like the number of acceptable mites coming back in a 300 bee sample, that percentage is getting lower and lower. And if you do any investigation into the practices of beekeepers that are successful consistently year after year, they're targeting 0. They're not operating on that economic threshold number. They're targeting 0, and they're able to achieve consistent success by targeting that number of 0%. So note that it has been demonstrated in research that Varroa infestation leads to reduced pupae body weight, irrespective of whether or not that tested pupae was parasitized with Varroa. So that's a big deal. So you would suspect that you would have reduced pupa body weight from a parasitized pupae, but they have such a drain on the overall colony nutritional status that pupae that are in a nest with the Varroa infestation that aren't even infested themselves with Varroa will have reduced pupa body weight compared to an uninfested colony. So that's a big deal. It's important to note. So I have a graphic here from a research publication on the effects of Varroa inside of a hive. And in scenario A, you have nutrition, immunity, and virus levels in a colony without Varroa. So you have resource collection by the foragers. They're bringing that nutrition into the hive that boosts up in-hive immunity. You have reduced viral levels from that heightened immune state. And then you have optimal brood rearing and adult longevity, which drives colony growth. So that's great beekeeping. That's the scenario that we want. In scenario B, you have nutrition, immunity, and virus levels in the colony with Varroa. So you have reduced foraging. You have reduced resource availability in the colony and at the individual level, and that brings down, so compromises the immunity, both social immune behaviors and individual immune responses. You have virus transmission during Varroa parasitism, driving up virus levels in the colony, greater brood mortality and reduced adult longevity, reducing colony growth, and that negative feedback loop continues, and it accelerates until you have colony crash. It's really important to understand the biology, the reproductive cycles, and understand what your treatment options are, and have a program that allows you to achieve as close as possible to 0% infestation. We curse winter as high latitude beekeepers, but it's our best friend. We really have a good opportunity in our low brood or broodless period of the year around the month late October into November to almost completely eradicate the Varroa infestation in our colonies. So really, if you're not already doing it, begin to better understand this cycle and what your options are to break that cycle. Okay, this graphic is... This graphic was produced by Randy Oliver of scientificbeekeeping.com. Randy used the data of a Canadian entomologist, beekeeper, and researcher by the name of Lloyd Harris. I had the opportunity to meet Lloyd several months back at a beekeeping event in Manitoba. Really good guy. I've had some email correspondence with Lloyd since then, and he was kind enough to provide me all of his published literature and give me permission to use it in presentations and that kind of thing. But I thought it was really, really cool that this is, I view this graphic produced by Randy Oliver based on Lloyd's data. I view this as probably one of the most significant tools that we have available besides effective miticides in beekeeping. When you fully start to understand or let it soak in what this graphical representation of the annual cycle of the honeybee colony allows you to analyze and what it allows you to plan around and what it allows you to do, I think you'll agree with me that it is a very, very fundamental tool. And it was created off of high latitude beekeeping data, so Manitoba. So it's very, very relevant for us northern beekeepers. So the first section, for anybody unfamiliar with this graphic, basically what it's showing us here is that going up the vertical axis here is showing us total population in the hive as it goes through the year. So we're running a time span here. This is one full annual cycle from January to December, mapping the total population, matching. So these numbers that are across here, 117, 77, 35, 15, that's the average age of the bees in your colony at that point in time throughout the year. And these different colors up this population axis are also giving you representation. So the darker colors are basically representing older bees. The brighter colors, red being the most young, so 0 to 12 day old, orange 13 to 24. You get the idea. This black dotted line is the average number of sealed brood, or cells of brood, in your colony as it goes through the year at different time points. So you can start to get an idea of how useful this is as a beekeeper to kind of plan what it is that you're going to be doing throughout the year. Now these arrows, red lines, are mine. I'm just sectioning out blocks of time. So this first section, early spring population dynamics, what's important to note here, and again, most beekeepers understand this, but this presentation is primarily, well, it's for the folks who don't understand what's going on at these times of year. So right here you have old bees basically coming out of winter. The average, at March right here, you have the average of 118 average age of 118 days in your colony. So those are getting to be some pretty old bees that have to start upregulate or ramping up brood production to get ready to take advantage of those early flows. And by mid-April, you have a large amount of cells of brood in the colony, and your average age of your bees there, you're getting into 117 day old bees that are taking care of this very large amount of brood. Like you have bees in your hive, average age of bees in your hive of 117, and then it starts as some of that brood starts to hatch, it goes down to 77. But you have bees in your hive that are 217 to 252 days old at this point in April. So that's a very aged demographic trying to take care of a large amount of brood, which is problematic when you have the variability in climatic conditions at this time of year. So, this is an all-in, to kind of quote Randy Oliver here, this is the all-in period, for the colony right in here. Now, the benefit of supplemental protein feeding here is that when the bees invest in this brood and then they get a bunch of cool weather sets in or rainy weather, you immediately within less than a 24-hour period of not being able to get out and forage, that large investment in brood will begin to be cannibalized by the bees to capture back that protein. So that's not great when you're trying to manage consistently. You don't want your bees to have to cannibalize the brood that they started to rear. So that's the advantage of protein feeding in the spring. Now timing and that kind of thing, I have my own strategy putting it in here. I feed a lot earlier than most people do in the spring. I start right around the end of February, but I don't want to give anybody advice on that because that's not a calendar date that I've picked. That's not an arbitrary date that I've picked to begin that feeding, and it's not every year that I begin feeding that early. There's a lot of variables that go into that decision. The weather patterns in the previous 2 months are very key for me to help me make that decision. If the bees have had ample opportunity to get out and make cleansing flights through the winter and leading up to this, like within that last month and a half, they've had a couple good days of cleansing flights. I'll make that decision comfortably to start around the end of February or the beginning of March to get those 2 brood cycles going until they can have some good consistent natural forage coming in, or at least start to get pollen coming in around the end of the first week of April, second week of April. But again, it's not an arbitrary decision. If my bees have been locked down and haven't been able to get cleansing flights up until this date, the last thing I'm going to do is go out and dump a bunch of protein supplement on them, because they're going to eat it if I put it there, and it'll cause a lot of problems in the hive if they haven't been able to clean their guts. So, you really kind of need to make up your own mind on when you start, that kind of thing. Or even if you do supplemental feed here, why I do is to even the playing field, to make sure that whatever investment in brood they've made, they don't have to cannibalize it due to variability in flight or foraging weather. So that's really all I wanted to talk about in that portion of the year. This portion of the year, I'm not going to spend too much time on it either, because beekeeping is... Oh, I'm going backwards here. My bad. Now, I'm not going to spend too much time on this section of the year here, because ultimately this is pretty much when beekeeping is easy. Lots of that, from May to the end of the second week of July, end of the first week of July. Lots of that. That's our main flow in this neck of the woods. So there's lots of natural forage coming in. The bees' immune response is robust. The population is strong. Colony level and individual level immunity is up, and it's hard to stop a beehive. It's hard to get in the way of the growth of a beehive at this time of year. So I don't really think that requires a lot of input from us as a beekeeper. Swarm management is typically our biggest problem there. We should be monitoring for Varroa mites, but typically beekeeping is easy at this time of year. Now, it's really this portion of the year that was the purpose of me making this presentation. Now, it's common knowledge. The benefit of supplemental feeding in this time of year. It's common knowledge that there really isn't a lot of value in supplemental feeding in this time of year. But what's often overlooked is we have two key points in the year. And, that spring turnover, it's well known and well talked about, and it's well practiced to get that population, to provide the colony sustained protein through that time of year, to get the population to even out those inconsistencies in the weather. What's less understood is the criticality of this time of year. So what you're looking at here, after about the second week of July, is you're looking at the queen's response to a couple of scenarios. One, the solstice has passed, and it's their natural inclination to start ramping down brood production. In high latitude regions. So they have the natural tendency to do that anyway, but you also have a direct response to a gap in natural forage. And what you're seeing here is the response when the fall flow starts to come back in. The brood, that fall flow is just enough to stimulate enough brood rearing to rear a nice little patch of brood that's going to send a nice young cluster of bees into the winter to get that beehive through winter with young bees. That's critical, and they can't be heavily parasitized with Varroa either, so it's out of the scope of this presentation, but you need to make sure that your Varroa mites are managed back here. Taking care of the bees that are taking care of the bees that are going into winter is the concept. But this drop in brood rearing right here, this is there's a lot of beehives that die, and my earlier statement on the second slide, I believe, of the presentation is that many managed bee colonies die each year from the reliance on natural cycles to produce adequate forage. And this is really what I'm talking about when I say that, is that if this fall flow doesn't come in an adequate amount, so you have a really dry July, and it doesn't set up those fall flowers, your goldenrods and your asters, to produce an adequate flow to stimulate that queen in the nest enough to rear this nice little patch of brood, to shift that demographic from all of these aged summer bees into a nice young nest again to ride that colony through winter, the chances of success of that colony go way down. And I can show you some hard numbers here on the next slide to back this up. So this isn't a unique concept. I didn't figure something out that nobody knows, but it's not popular. It's not common knowledge enough, and I wanted to take time to make a presentation that discussed it, because we do this well as beekeepers, but it's not as common to understand what biological processes and how those that are going on at this time of year, and how those biological processes are tied to the annual cycle in our region in high latitude areas. Now this isn't going to be as dramatic in all areas. Some areas may produce an adequate flow all the way through, right? So everything's regional here. But for me in my area, and I know in a lot of other areas in Canada as well, you do have this gap right here, and basically you have variability. You have variability in how dry this month is. So you ultimately have variability in how well the fall flow comes in, and what that looks like in terms of the numbers. So how that translates out into annual losses in New Brunswick specifically. So I went into Environment Canada's historical weather records, and I went back to 2011, and I took the data sets available from all of the weather stations available across the province of New Brunswick, and I recorded or pulled out the number of rain days recorded for the month of July at all of those weather stations from 2011, 2012, all the way through to 2018. And I just took the average down at the bottom of each one of these columns. That's the average number of rain days across the province of New Brunswick. And then I went to the CAPA reports and got the annual loss rates corresponding to each of those years in New Brunswick. So what I've done is I've kind of put that into this spreadsheet here, and then populated this graph with that information. So in this column here, this is the average, or this is the average number of rain days recorded in each season, and this is the average loss rate recorded in each season. So we could show, do a comparative analysis. So this represents the average. This is our average loss being represented from 2011 to 2018, and this is our average rainfall in days in the month of July, averaged from 2011 to 2018. You can see in the season of 2011-2012, we had about an average amount of rainfall. Correspondingly, we had about an average annual loss for the province of New Brunswick in that season. In 2012-2013, the rainfall amount dropped down considerably. Corresponding to that, our loss rate goes up considerably in that season. The following season in 13-14, the rainfall amount goes up a little bit in number of days in July, and corresponding to that, the loss rate goes down a little bit for that season. The next season, 2014-2015, the rainfall amount goes up just a little bit from the previous year, and then the loss rate also goes down a little bit from that previous season. The next year, 16-17, the rainfall goes up a little bit more, the loss rate goes down a little bit more. Next season, 2017-2018, fairly dry in terms of a number of rain days in July. That drops down quite a bit, all the way to 6.18 rain days, and the loss rate jumps up in response to that. So basically, what's going on here? Like I don't have to. I can tell you in average terms without speaking to every beekeeper in the province. I can make a generalization by looking at this data and by understanding the biological cycles that a honeybee goes through at that time of year. What I can tell you, based on this data and the known biological cycle of the honeybee in response to its natural environment, I can tell you that the primary practice in the province of New Brunswick is to leave the honey supers on and not touch them until after the fall flow. They go on and they don't come off, and supplemental feeding is not occurring. Now, it's not to say that every beekeeper is doing that, but on average, the data doesn't lie to me. That is what's going on. And maybe that's fine, and maybe everybody's good with that, but I just wanted to point out that what is going on is when July is too dry to set up the fall flowers for an adequate flow, there's not enough stimulation response out of that dry fall flow to produce an adequate number of young bees to push that colony demographic to a younger state and hence get the beehive successfully through winter. Now, again, a lot of beekeepers are aware of this and have taken steps in their apiary to avoid it. I need to go back, is what I'm trying to do here. A couple slides, just bear with me. All right. So, having taken that into consideration, what I've done to help me gain a little bit more control over that scenario. So again, for the same reasons that we provide supplemental protein here to even that playing field out for our bees, I've added in an additional step in recent years in my beekeeping to even out the playing field at this time of year. So my honey production stops when my bees get back from cranberries. Everything gets pulled off. So that's towards the end of July. Everything gets pulled off. What I've made in the main flow is it for me. I immediately take that honey off and I begin supplemental feeding. So protein for me is a fairly constant practice. I don't want my bees experience protein stress because either I'm going to be spending it in antibiotics to fight off brood diseases, or I'm going to be spending it in protein. And I don't have brood diseases in my apiary, and the reason I don't is because I invest rather than investing it in prophylactic or in response medications. I prophylactically keep their immune response robust with supplemental feeding. So the protein is pretty constant for me. But by taking all the honey off here, arguably I'm sacrificing some profit, but you also have to factor in how much honey is worth a pound, and you have to factor in how much honey your hive is going to consume through this dry period, right? So you're also losing, honey there. Sugar syrup costs me about 50 cents a pound, and you can cheaper than that on larger volumes. So it's, you have to do the own math. You have to make up your own mind. I'm not trying to tell anybody that what I'm doing is any better than what you're doing. So take me with a grain of salt. But I have been able to, gain a lot more precision over my overwintering outcome. Below 10% is what I'm gunning for. 15, I consider that on the high side. And all I can tell you is that I've been able to achieve a lot more consistent overwintering success by implementing this practice to make sure that I have this brood rearing taking place consistently in my hives. So by taking all my honey off here and stopping honey production, I do my splits. I come back off of cranberries. I take out any excess. They're all ready to swarm on me at that time, and I lose a bunch to swarms. Blah blah blah. So I take off the excess. I make up other colonies. It's a little bit late in the year, but you just make them bigger. And I immediately begin pulse feeding syrup to keep a stimulated flow coming on into those hives. And I'm heavy protein feeding, basically whatever they'll take at that time, because it's much easier for me to maintain that momentum. If I let them shut down, completely here and then try to restart them again, it's hard. They're naturally inclined to slow down their brood rearing at this time of year. So it's not like spring stimulation feeding. They want to grow here. But if your timing has to be, it's very critical here, because if they start to lose momentum, it doesn't matter how much you want to spend on supplemental feeding after they shut down in the fall. They're not going to restart again on you. It's just a biological fact of honeybees. You need to your timing is everything. If you want to employ this strategy, you got to get it on them and start getting the pulses of syrup in them and protein on them before they shut down. That's just the name of the game here. And what you're able to achieve by doing that is lessen the amount of shutdown that you get and smoothen this out a little bit. Smoothen that out so you end up with consistently, I know at least I'm going to get this, but ideally I'm going to be able to smooth this decline out, and I end up with a larger pulse of young healthy bees to take my colonies through winter. And the proof is in the pudding for me. I wouldn't be doing it if I haven't seen the results that I was trying to achieve. So if you want to remove some of the seasonal variability out of your operation, this is one way to do it. So again, I'm not trying to tell anybody how to keep bees. I'm just trying to share some lessons learned, from my operation. So again, I know it's common knowledge to do it here, but there's also advantage at the apiary level to supplemental feed here. Now you do have to, again, because of the syrup feedings, you do have to collect all your honey before you start, and that's kind of the end of that game for you. But again, do the math. How much, weigh your hives before that part of the season, weigh them when the fall flow starts, run the math and see how much they're actually consuming. There's a lot of hungry mouths in the hive at that time of year, right? So I think if you do the math on that, you'll find that in a lot of areas, not all, in a lot of areas, that you actually be you'll actually be saving money by going through that exercise. So again, just to recap, there's a tick for tat correlation between how dry July is and how well that fall flow gets set up and the number of colonies that die every year. Year after year, she's boom, 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 boom. Correlation doesn't prove causation. I get that. However, when you pair up this hard data with, you pair up this correlative data with the known biological cycles and how they respond and what their natural inclination is, at that time of year, there's a pretty clear picture there. It's enough information or enough data for me to make apiary level decisions off of. So winter population dynamics, again, that's, hold on here. Winter population dynamics. So again, here we're trying to provide supplemental feed to set up the productive unit that we need to meet the needs of our apiary, whatever we're trying to do with our bees. This is why we want to provide supplemental feed in this area, is to make sure that they don't go into protein stress. The purpose of this presentation was to bring some attention to this protein and lack of flow at this time of year, and what it ultimately does to the age distribution inside of your hive as you're going into winter, and how that directly translates into overwinter mortality rates here in the province of New Brunswick. So that's it. You want young bees, and there's 2 key times a year that we need to be focused on supplemental feeding, and it's not only spring. Okay, so I'm going to read an excerpt from scientificbeekeeping.com. And again, this is from Randy Oliver, and this is a quote from his website. The honeybee colony is a biological system that goes through an annual cycle that is tied closely to the progression of the seasons, and that's basically what we were just looking at. The successful beekeeper must always be aware of this fact and make sure that his management is timely. Timing is everything. Nature does not accept excuses nor delays. Supering up halfway through a honey flow is too late. Feeding after a colony has shut down brood rearing due to protein deficiency is also too late. The beekeeper needs to be observant and proactive. If you want to maintain colonies that are as big as sumo wrestlers, they must continually eat like sumo wrestlers, either from natural forage or by supplementation. You can't wait until the last minute to beef up a contender. Feeding only in late fall or winter may be too little, too late. This point was brought home with a vengeance to California beekeepers this season. Our early summer drought shut down colonies in July. Those beekeepers who began supplemental feeding in July now have much stronger colonies than those who waited until August. It is easy to lose colony momentum. Once they start to ramp down due to dearth, they are much harder to restart than they are to maintain with minimal supplementation. And that holds true in the foothills of California, but it's even more true here in the month of July and August, pushing our bees into the flow, because our annual cycle is much more pronounced. Our ramp down in brood production, their natural tendency to ramp down to almost nothing by mid-November for brood production, we're also fighting that biology at the same time. So that momentum is much easier to lose and much more difficult to restart at that time of year for us. So again, timing is critical. Timing is critical to maintain that brood rearing momentum of that colony at that time of year to produce that young nest that we're looking for. So here's another nutritional stress tip from Randy Oliver. The outcome of a stress event is often not apparent until a month or more later. When you see colonies having problems, it may be due to a stress event that happened 2 or more months ago. Beekeepers with problem bees would do well to get into the habit of looking back at events a couple of months prior in order to try to figure out what happened. Note that one of the common denominators of CCD colonies was a stress event 2 or 3 months prior. There is a lag time for the consequences of nutritional stress to appear. It is easy to be caught by surprise, and then it may be too late to do anything about it. So that's a very important point. Now that lag time for the outcome of a nutritional stress event to appear, I would argue that our first indication that we had a nutritional stress event in July, August, and September, at least in the province of New Brunswick, and I would argue in probably in a lot of regions for high latitude beekeeping, our first indication is a dead out box in the spring. Everything looks fine. There's still populace in the fall, but those are old bees. So the outcome of that nutritional stress event that occurred in late summer, early fall, the result of that, the end result, or the first indication that we have is our dead boxes, our dead outs, a few months later. I found that by wintering strong, pollen-rich colonies with plenty of quality honey stores, that there is no need for spring syrup feeding. So that's another point, and I agree with that 100%. I just can't say enough about the work of Randy Oliver, man. The guy just makes so much sense. Very, 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 very happy that his resources are available to me to help me make decisions and help me make sense of some of the problems that I'm trying to solve. But I couldn't agree more with that last statement. And, one of the advantages that I feel like I have by, cutting off my honey production season, at the end of July or mid to end July, is that I get to mix my syrup with some honey. Now, I know that there's, variation. Some honeys, it depends on where you're at, whether you can do this or not. Some honeys crystallize, some honeys have too high ash content, and, the research is fairly clear on, bees wintering better on, sucrose syrup because of that fact. It's just cleaner. It helps them, keep their guts in a it avoids dysentery problems basically by having you can have more quality control over the winter stores. But there's compounds. I've done a ton of reading and research into the specific phytochemical compounds in pollen and nectar, and the benefits that those phytochemicals confer to the host as they're consuming them. And it's very, very clear in the botany and entomology literature that the compounds that are in pollen and nectar, and by extension honey, are key in keeping the honeybees' detoxification systems and their immune responses robust. So I like to have some honey in my winter stores. I do like to dilute it down. I like to have quality control with syrup feedings, but I think that there's advantage to having a mix of honey and sucrose syrup in the fall. So I just kind of wanted to touch on that. So spring stimulation or insurance policy feeding, this one's the common knowledge one. So when or if the beekeeper begins this exercise depends on, a number of things. What are your objectives for your bees? What is your objective? Is it splits and nukes? Is it honey production? Is it pollination? Strong colonies to produce swarms? That's, not the objective in most apiaries, but some hobbyists do enjoy to see that. And, a lot of us, smaller apiaries that are trying to grow end up doing this, and not by any not by trying to do it, but we end up doing a lot of it anyway. And then is your objective to maintain smaller spring colonies to avoid later swarming? So whether or not you do conduct supplemental feeding exercises in the spring, and the timing of that activity really depends on your area, the timing and predictability of your early flows, and it depends on your objectives as a beekeeper. Late summer stimulation feeding. So this is the time when it's a little less commonly applied or common knowledge as to what the advantages could be to having a good supplemental feeding and nutritional strategy being employed at this key juncture or for this population turnover. But it can be a little bit tricky to find the right balance, and it took me a while to figure this out as I was first starting to keep bees and figure out the timing of it. Timing and quantity is important here. So if you feed too little, the desired stimulation does not occur to produce this predictably. If you feed too much, the colony becomes syrup honey bound too early, and subsequently they shut down brood rearing too early to produce the desired colony demographics for fall and winter. If you feed too late, like you push that feeding program out too late into the fall, you have risk of late winter dysentery, either because they haven't consumed, either they haven't been able to fly out and get rid of the pollen supplement out of their guts, because like this year here was a very early lockdown in fall just set in, and winter just set in October here this year in New Brunswick, and that's not normal. And I have a nuke yard that was going, like I had a lot of protein on them because I like to have those nukes just busting with bees to help get them through the winter. And my late feeding, I got kind of caught in that nuke yard. They didn't fully consume and have time to make adequate cleansing flights, and there was some dysentery being expressed in those colonies. Later on in the winter because of that. They're fine now. They've got enough cleansing flights, but it does take a toll on the colony. So it's very important here to understand the timing. Like for me, like I have it in typically what I'm trying to gun for, I was like, end of September was my, end of September was my, first week of October was my all pollen patty off kind of time that I cut for myself. But every year, you kind of just, you learn a little bit more, and you kind of get a little bit wiser, and you figure out your timing a little bit better based on your observations. And so I think I'm going to cut that back, a little bit to give myself another week or two in the fall. So I'll feed them basically right at the last week, or the first week, or last week of September. I'll probably, anything that's not consumed on the colonies at that point in time, I'll probably take it off. That's just to make sure, again, these early winter set-ins like we got this year, that I don't get my bees locked down with their guts full of pollen supplement. So you need to employ some intelligence here. It's not all about just arbitrary feeding. It's not about, hard calendar dates. You have to pay attention to the season, and you have to have some, practical strategy. So how early I start to feed is dictated on how many cleansing flights the bees were able to get in the late winter. And again, I'm still adjusting this date back a little bit as I'm getting a little bit better at understanding, what our fall cycles are like, late fall cycles. So again, you need to employ some intelligence that you'll have to figure that out yourself. I can't give anybody hard dates or advice on how to get this, because I'm still dialing it in myself. But overall in my operation, there's better overwinter success more consistently by addressing this scenario, by supplemental feeding through this. I get nice young bees. October, I still have lots of brood in most of my colonies from doing this. Okay, so I just threw up a little video here. So this yard is one of my, it gives a good example of how bunched up bees can get when they're being managed for pollination. So this yard here, I need to get some more yards like this that I can get my trailer backed right down into, and I can load this yard. I don't have neighbors in this yard. I can load this yard right up full of hives. And one of the, it doesn't seem like it's going to play here. I'll just put it on pause there. So I guess I wanted to show this slide. So this yard, I think there's about 65 colonies in this yard, something like that. One other thing, I need a few more yards like this. It's kind of, I'm on the hunt for that right now. I can jam a bunch of bees in. Basically, I use this as a staging yard, one of my staging yards, to kind of get things ready for pollination events, and to bring things back from pollination events. So this is after cranberries last season. So I've broken these colonies down. I've taken all the excess out of them. I was a little bit late. I do lose some to swarms type of deal, but I've taken the excess out of these. I've broken them down. I've taken all the honey is out of them, and I'm now beginning that late summer stimulation feeding to maintain that colony momentum. Now these buckets aren't full. These got about 2-pound protein patties on them. And these buckets aren't full. There's about 2 liters or so in these buckets. And on a weekly basis, they just get a little flash of syrup to keep them going. Now, there is an investment in that, but that investment pays off. So again, I'm trying to time this out. So as soon as I can get them back, as soon as I can get the honey out of them, as soon as I can get the splits that I'm going to make made and get them broken down so they're not going to swarm on me, then I'm start like little flashes of syrup and lots of adequate, nutritional protein supplementation to maintain that colony brood rearing momentum. And these little flashes of syrup will help me avoid, backfilling that colony. A little couple liter flash a week won't backfill them, but it's just enough stimulated flow that they'll continue that brood rearing right into October, and that's ultimately what I want, so I can have nice young colony demographics going into winter. And that's pretty much the bulk of that plan, and that is it. That is what I wanted to talk to you about. I'm not sure if there's anything in there that, maybe everybody already knows this, but only thing I can do is look at the data for New Brunswick, and I would say by looking at the data, one of two scenarios is either it's not common knowledge, or people don't want to employ it. One of the two, and those are all both very plausible or possible scenarios. Probably a little bit a mix of both. So again, I'm not. Take me with a grain of salt. I'm not trying to tell you that you should be doing this or that this is better than how you're currently doing things. It's just to open up the doors to my operation as I'm employing strategies that are producing results for me. I will share those strategies with you.